Hello. Sometimes we may be given two straight lines and asked to show if they are parallel, perpendicular, or neither. Now, to show if the two lines are parallel, perpendicular, or neither, we look at the slope of each. We must compare their slopes, and the slope can be found in the slope-intersect form, which is y equals mx plus b. So in this form, the slope is the number in front of x. So here is the slope. So let's look at a few examples, 4 examples, and see if we can decide if the two lines are parallel, perpendicular, or neither. We will do it by hand first, because when we are on the test, usually we are asked to show the work by hand. So in order for us to earn the credit, we have to be able to do it with just pencil and paper. Then we will also use calculators sometimes and discuss the limitations of if there are any. So let's look at the first example. Suppose I have two equations. The first is y is 3x plus 4, and the second is y is negative 1/3 x plus 8. To see if they are parallel, perpendicular, or neither, I have to look at the slopes. And both equations are already solved for the y, so I don't have to do that anymore. All I need to do is look at the numbers in the front of x. So the slope from the first line is 3/1, and the slope from the second line is negative 1/3. Now, we notice that both numbers have opposite signs, and the numbers are reciprocals. They are flips of each other, meaning that the first is negative reciprocal of the second. When we see that happening, that means that the two lines are perpendicular. So we can say that M1 is opposite, is negative reciprocal of M2, which means the answer is our two lines are perpendicular. Another way to show mathematically that the two lines are perpendicular is if we multiply the two slopes and the answer happens to be negative 1, that also shows that the two lines are perpendicular. So here we can do that as well. M1 happens to be 3/1, M2 is negative 1/3. When we multiply fractions, we multiply straight across, top by the top, bottom by the bottom. 3 times negative 1 is negative 3. 3 times 1 is 3. And of course, 3 goes into 3 ones, but there is a minus in front. So we get negative 1. And that proves mathematically that the two lines are perpendicular. So the answer to the first question is the lines are perpendicular. Now, with a calculator, this is one of the limitations of the graphing calculator. Let's make a sketch and look at the picture. So here is old equation. Let's type in the first. We have 3x plus 4, and the second equation is negative 1/3 x plus 8. So let's have a look at the picture. Here comes the first line, and then the second line, and they crossed, and it looks like it is not obvious from the calculator. Here is the picture up close. It is not obvious that the lines are exactly at 90 degrees. They may, in fact, they look like a little bit more, maybe by a few degrees more than 90. And the reason that is because our window is not perfectly square, it's rectangle. It's actually longer horizontally than it is vertically. So our picture is actually distorted, and none of the angles happen to be exactly as they are, which is why we cannot use this picture on a test to prove, or on a homework, to prove that the lines are perpendicular. we can use it ourselves to see that they look like they may be, but that's not the exact proof. So for this particular type of lines, the calculator is not very useful. Now, for the second equation, it will be. Now, let's look at 2x plus 3y is 10. And the second equation is y is negative 2/3 x plus 8. So we notice right away that the slope for the second is already given. We can see that it's negative 2/3, but the slope for the first equation we don't know. And to find it, we have to solve this equation for the y, and that means canceling 2x. We can minus 2x from both sides, and that makes 3y equals 10 minus 2x. Now, to cancel multiplication by 3, we divide each term by 3. We can do it all as one or separately. It is easier to reduce if we divide them separately. So 3 does not go into 10, leaving 10/3 minus 2/3 x. Now this is not really in the slope-intersect form, because in slope-intersect form the x comes first and then the b. So let's rearrange it. Negative 2/3 x plus 10/3. So the slope for the first line, now we can see, is negative 2/3. So m1 is exactly the same as m2. So here, let's type in both equations. What that means is, of course, that since both slopes are the same, the tilt for both lines is the same. They're both negatives, so both lines are going down with exactly the same tilt, which means the lines would be parallel. And we can say, since m1 equals m2, this means the lines are parallel. So on a test, this would be our justification by hand that the answer is the lines are parallel. Now let's look at them with a calculator. So go back to y equals, clear the screens, and type in our first equation is negative 2/3 x plus 10/3. The second is negative 2/3 x plus 8. Now as we type it in, we notice right away, of course, that the slopes are the same, but we also notice that the y-intersect, the b numbers, the b numbers are different, and that means there is a space between the two lines. So they're not the same line, they're actually two different lines. Here comes the first, and here comes the second, and we can see that the two lines do appear to be parallel. So in this case, the calculator is actually useful because we can see that visually that the space between the lines is not getting bigger or smaller on top or on the bottom, so they look exactly parallel. We could try to zoom out if we wish to see them a little bit further out. If we hit zoom, the third choice is out, and we can look at them a little bit further. So here is much smaller grid, much further out, and they still look like they're running exactly side by side, and they're not going to cross. So here with the calculator we can see that the lines are actually parallel. And that finishes our second example. In the third example, let's look at first equation is 3x plus 2, and the second equation is 1/3 x plus 1. Now both are solved for the y. We can see the slope from the first is 3/1. The slope for the second is 1/3. And so we see that the numbers are reciprocals of each other, but they're not negative reciprocals of each other. The signs are not opposite, which means these lines are not perpendicular. the slopes are different, which means the lines are not parallel either, which means the lines are neither parallel nor perpendicular. And that is our answer for the third example. Now in the fourth example, let's look at two special cases. The first is x equals 3. The second is, is y equals 3. Now the second is actually a horizontal line, so let's sketch them. Second is horizontal line running through y equals 3. 1, 2, 3. So somewhere here is a horizontal line, and that's our second equation. The first is a special case, and it's a vertical line running through x is 3. 1, 2, 3. So, of course, well, that is off quite a bit. So, of course, vertical and horizontal lines are at 90 degrees to each other, so they would be perpendicular. And so the answer is perpendicular. Now, to see it with a calculator, we would need a special feature. So here is the y equals 3. That's our horizontal. Now the x equals 3 cannot be inputted through this window. So we have to exit, quit, and then go to the draw, which is second program, and go to the vertical, which is choice 4, enter, and then type in 3. That makes vertical line through x is 3. Here's the horizontal and vertical. Now I need to change the window back to original. So zoom, choice 6, goes back to standard window from -10 to 10. So here's what it should look like. Horizontal through 3, and then I forgot to put the vertical each time. So vertical through 3. So here is what it looks like with a calculator, and we can visually see that the lines are actually perpendicular to each other. And that's it for this video. That's how we can tell if the lines are parallel, perpendicular, or neither. We'll look at the slope for each. And if the slopes are negative reciprocals, they are perpendicular. If the slopes are exactly the same, they are parallel. And if that doesn't happen, they are neither. And that's all. Thanks a lot for your time. Take care.